What are some questions that we can answer on these? Well, I'll give you a few, right? So the questions, now you've already got this here, you don't have to copy this down. I think we copied that down in our first lesson. And we also did questions similar to this, but we'll just do them again for good practice. So I'm going to choose this one over here.
Wait, what do you mean this rule?
Say that again, sorry?
What was the point of this rule?
The point of this rule is we're going to answer some questions in a moment that ask you, okay, here is a normal distribution, right? And they give you some information. For example, they might give you the mean and the standard deviation. And they want you to find what percentage of scores lie between certain scores. Exactly, yeah. Yeah, so in your textbook, I actually started with this, but in your textbook exercises, for some reason, they've put it kind of underneath. They've put it after all the function stuff. So, I mean, I started with it, and then I just did it really quickly, but we're just going to go back and revisit all of the questions there. Yeah, is that fair? So, actually, I want to start with B, because B's easier, I realized. So, my A is going to be the B that's there, so. When you're doing this, like I'm a very visual person, so I really like to draw diagrams to help me with this, right? Some of you maybe will just do it straight up, and that's fine. But yeah, I'm always going to do a visual representation. And so I've been practicing my normal distributions. Let's see how well we go.
Distributing.
What was that in the one?
Sorry.
How's that?
Pretty good.
Pretty good?
Looks like a...
And then we got a little line going on over here.
Can we open?
Oh, what? Why did it just turn into a triangle? Jeez, Louis. It's because on OneNote there's this mode where it corrects your shapes. Yeah, but for some reason I just turned into a triangle. Let's go back out of there. We don't want that. All right, let's turn that mode off. We don't need that one. Let's try again. Here's my straight line. There we go. What do we got here? We have our mean of standard deviation. So remember the mean goes into the middle. So that's 65.2 here. Now what you might want to do is, in your formula sheet and stuff, they write the z-scores there as well. So you might find that helpful if you'd like to. You don't have to do that, but that should probably be on another grid. So like these here would represent how many standard deviations away from the mean that your score is. But then the number itself would be the actual value. So 65.2 is our mean, right? And then how do we get our other values? Well, we should be adding the standard deviation on each time, right? So we do 65.2 plus 1.3. So what's that, 66.5? Man, maths is hard these days, yeah? You got the other ones, James?
No, I just confirmed that.
Oh, okay. Do you want to do the rest of them for me?
Do I have to do them in my head or can I do them in my
You didn't do any calculator for me.
So 67.8 for the next one. That was from the head, that was off the dome.
Oh man, big brain.
Yeah, 63.9 the other way.
69.3?
No, like on
What?
the other side.
Oh.
Yeah.
63.9. Okay.
62.8. Wait, no, 3. No, 62.6.
Yep.
Big brain, yeah.
Big brain.
61.3.
Yeah.
Wow.
Are we missing one?
Wow.
Yes, that one.
67.1. Okay, so there you go. And that's just a visual representation of what's kind of going on here. You don't necessarily need that green bar. That's just to kind of indicate the the z-scores. Might be a bit confusing right now because we're not dealing with z-scores exactly. Yeah, it's a spoiler. It's in the next exercise. The z-score is how many standard deviations away from the mean it is.
We already did that.
We did do that. That's why, we're going back to it. So he's definitely trying to trigger me, isn't he? All right, 61.3 and 65.2. Right. So remember how I said that we have our empirical rules, right? And our empirical rules state the percentages that these fall under. So we want this section over here, though. So we know between one standard deviation, -1 and 1, that's 68%. -2 and 2, that's 95%. And -3 and 3 was 99.7%, right? And so this one, oh, Maylin, how'd you do this one?
I added them up.
Yeah?
No, okay, so
No, that's fine. So how'd you do this one over here?
well, I did 68 divided by 2.
Yeah?
Plus 95 minus 68 divided by 2.
Yeah?
Plus 99.7 minus 95.
I like how you thought like that because I kind of thought like that, right? And then because I realized that this is content overlapping with standard maths, then there's probably usually an easier way to approach these kind of questions, right? So what Maylene seems to have done is like added up these kind of relevant sections. Is that what you did? Can anyone see another way you might have wanted to do it?
So 69.1 divided by 2. Wait, yeah, minus 1. And then do the opposite.
Yeah, exactly. Yeah. So this is what I mean. Mathematics, you guys, right? Because you're used to dealing with calculus, you tend to overthink things a lot. And tomorrow I was like, hey, can't you just halve the area of the, the 3 standard deviations away, 99.7, and then halve, and halve it, right? But then you may not everyone thinks like that. Not everyone thinks like that automatically. Like when I thought of it, I did the exact same thing you guys did. I started, I have to add up this section and this section. It's going to be such a trek, right? But what I want to encourage you is that you need to be looking for kind of, not smarter ways to do it. It's just like, is there a more obvious way to do it? Is there an easy way to do it? Because firstly, it's quicker. And secondly, it's probably less error prone as well. You're probably going to make less mistakes. So actually what you want is you just want half of this section over here, right? So we want half of 99.7%. So half times that. What was that? 49 point something. 85?
Yes, A-bar.
Perfect. Cool, awesome. Part 2 was between 65.2 and 66.5. Let's have a look. 65.2 and 66.5. Harry, how are we going to do this one? Oh, there we go. We got the efficient way. So again, which section does it match up with? Well, it's between one standard deviation, so -1 and 1. And we know that contains 68% of the data. So like Harry said, we're going to halve that amount. So half of that.
Harry, how are you just
I don't know, man.
Lawan's going to do the next one for me.
No, I shouldn't say. I've honestly been catching up because I'm late, so I don't know what's going on.
Oh, is that right? Maddie, do you want to help him out with the next one? Let's do part 3 together. So 62.6 and 69. Ooh, this one's a bit trickier. Be careful.
So you've got the rate, the percentage of the scores that lie between 61.3 and 65.2 already, which is 49.85.
Okay, so I already have this here, which you're saying is
65.2 and 60.
so I've got this section here.
No, the other
No?
side.
61.3 and 65.2. That one? Sorry, which one?
But but it's symmetrical.
Oh, okay, right. So it's symmetrical, so you can put that to the other side as well, is what you're saying?
Half of 95.
So that's the same as, because it's 3 standard deviations, it's the same as that whole thing there?
Yeah.
Yep, that's good. I didn't see, it turned red. That's pretty cool. And then what did you want to do after that?
And then you just said half of 95.
Right, and then you can add half of this section here, because this is 2 standard deviations away, and it's half the area. So you can see everyone thinks differently like that. So again, just to recap, what Maddie's done is she said, okay, we already have this from the previous answer. So what I can do is I can take this amount and add half of the 2 standard deviations away, which I have, which is 95%. So what would that be? That would be 49.85% plus half of 95%. Does that make sense? Right?
Hey, sir.
Yeah.
Could you just minus the
Good.
-3?
So, and this is what I mean by there's lots of different suggestions, right? Harry's saying, wait, is there another way you could do this? Let's suppose we didn't do these previous parts. Another way you might want to think about it is, okay, if I want these sections here, I want from 62.6 and 69.1, right? Just like that. You're thinking, hey, this is kind of like probability when you're like, I have everything except one little bit, right? All you want to do is you want to take away this kind of green bit over here. And what you is anyone following what Harry's saying? Or?
Yeah.
Yep. So he's saying like, hey, what is the area between 61.3 and 69.1? Between 3, that's between 3 standard deviations, right? So that total area would be 99.7. Yeah? Are we tracking with this? Yeah, yeah. So that whole area would be 99.7. But we want to take away something, don't we? What do we want to take away? The green bit. Right, how could we find the green bit?
99.7 minus 95 divided by 2.
Right, exactly right. So what Tamara's realized is that actually, if you think about the green bit over here, right, the green bit is essentially this kind of extra bit over here, right? Because what happens is between 2 standard deviations, we have 95%. Between 3 standard deviations, we have 99.7%, right? So the green bit must be the extra bit that goes between that. Can you see that? Right? So the green bits all add up to 4.7%, right? So the extra amount that's there, right? But as Tamara realized, hey, it's symmetrical, so we only want half of that. Yeah, so we only want half of this. So we want to take away half times 4.7%. So hopefully these give us the same answer. Can we calculate both of them and see what they get? What did you get for your method, Harry? You want to put it in your calculator for me? Good man. And who did this way? Was it Maddie, I think? Do you want to calculate that one? See what you get? What did you get? 97.35%. And fingers crossed, Harry, we get the same thing over here?
Thing, yeah.
0.7.
Yeah, 0.7.
Oh, we got it. 97.35. Good man, good man. Any questions about that so far? I'm having fun with this.
Wait, so,
Yeah.
sorry, can you just explain when you got the 4.7 again?
Yeah, sure. So again, it's about multiple. Did you get the first way that Manny did it? Yeah. So it's about just giving you a few options, right? Because they may give you certain pieces of information and you may need to work around it. So Maggie's asking, hey, how do I get this guy over here? It's because, right, between -2 and 2, it's these highlighted sections, right? And I wanted between 62.6 and 69.1. So that's this extra bit here, right? But if you think about it, what you could do is you could find from here to here, but then what's the extra bit that I've counted? What's this left section here, right? So I'm trying to find what that green section is. The way I can find what that green section is if you think about the difference between 2 standard deviations away, so these two, and 3 standard deviations away, so these ones here. What's the extra bit that's captured? Well, this is 2 standard deviations. 3 standard deviations also captures this extra bit. Does that make sense so far? So this extra bit here, this total here, is 4.7%, because that's the extra bit I have to go from 2 standard deviations away to 3 standard deviations away, because it's like, this amount here is 95. This whole amount here is 99.7. So then those green bits together are going to be 4.7. But then what do we have to do? Because we don't want this bit here. We have to halve it, right? Does that kind of make sense? Yeah. Great. Awesome.